All right, hi class. So today we're going to be talking about subtracting fractions. All right, so we're going to start with subtracting fractions with like denominators. Our first one we're going to try is 4 6 subtract 3 6. If you want to grab a piece of paper and a pencil, pause for a second and run and grab a piece of paper and a pencil, and you can do this with me. All right. Okay, go grab a piece of paper right now, quick. Get a piece of paper. Okay, all right, hopefully you have a piece of paper, and we're going to write 4 6 subtract 3 6. And on a few of these, we're going to draw some pictures just to kind of get our minds thinking of like, okay, what's really happening when we're subtracting a fraction? Well, we're starting with 4 6, so we have to make a little fraction that has 6 pieces. So I always like to make 6 pieces by cutting it in half first, making 3 on one side and 3 on the other side. Then I can keep them nice and even. So I'm going to shade in my 4 out of the 6 to start with, because that's how many sixths that we have to start with. And now I'm just going to subtract off 3 of them. So I'm going to switch colors here, and I'm going to say, where my darker color went. I'm going to X off 3 of them. 1, 2, and 3. So how many sixths do I have left over? I have 1 sixth left. Now if you notice in our algorithm here, our denominators are staying the same because that's just telling us the denominator's job, right? The denominator's job is to tell us how many it is to make a whole, which, did we even start with a whole? No, we didn't. We only had 4 out of our 6 there. So then we took off the 3 of the 6, and we ended up with 1 of those 1 6 left. We could have labeled each one of these 1 6, 1 6, 1 6, 1 6, 1 6, and 1 6. Okay, now let's try another one. I was going to point out too. So really, what's happening with our numerators and our denominators? Well, denominators are staying the same, and numerators are the things that are getting subtracted, right? 4 subtract 3 is 1. Pretty simple. Okay, now we're going to try another one, and you're going to write this down with me. 5 fifths subtract 3 fourths. 5 fifths subtract 3 fourths. All right, now if I'm going too fast, you can always pause. So we're going to start by drawing our 5 fifths. And I'm going to divide this into 5 equal pieces. And all of my pieces are shaded, right? Because 5 out of the 5 are there. So I could almost even rename that as 1 whole. But I want to keep it a fraction because I've got, oh shoot, this is not, sorry. I messed that up. Oops, sorry. I meant to put fifths. Oops, we'll get into unlike denominators. I know some of you are getting excited. Okay, so we are going to subtract off 3 of those fifths now. 3, 1, 2, and 3 of them. And how many do we have left? We have 2 of those fifths left. Okay, so what's happening in our algorithm? We're keeping our denominators the same because they're just telling us how many it takes to make a whole. And we're starting with 5, we're taking off 3, and we're ending up with 2 left. Okay, pretty simple, right? Okay, now we're going to do one more. And this one is going to be 4 tenths subtract 4 tenths. 4 tenths subtract 4 tenths. This is going to be a great picture, right? Okay, we're going to have how many pieces? I'm going to cut it in half and have 5 here and 5 here, okay? So 5 there and 5 there. So we have 10 pieces, and we're starting with 4 of them. And we're going to take off how many? of them. I know you guys are already guessing the answer. I can already tell. Okay, so how many did we end up with? 0/10, right? There's nothing left. We have 0 left. Okay, so that was an easy one. Okay, now what if we have an improper fraction? Okay, so on this one, we're going to have 14/10 subtract 3/10. Okay, now I know you're already thinking in your head. I know our denominator is going to be tenths, right? And now I can just subtract 14, subtract 3 is what? 11, right? 11/10. I could draw a picture of that. I'd have to have 10/10, right? 2, 3, 4, 5, 6, 7, 8, 9. But then I'd have to have some more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces. And I have this whole one is filled in. And then I have 4 more pieces filled in to make 14 of those tenths. And so now I'm subtracting 3 of them off. 1 and 2 and 3. And how many do I have left? Well, I have 11 of those pieces. 10 plus 1 more is 11/10. But how could I write this as a mixed number? Well, you can see that there's a hole here, can't you? This whole piece right here is a hole. Now, what if I kind of represented that with a number bond? What would my number bond look like to represent this whole piece right here? I have 10 pieces and all 10 are there. 10/10, right? So 10/10 would be my whole. And what did I have left over? I had that one little 1/10 piece left over. So now if I bonded my 10 and my 1 together, I would have 11. So we could say I have 11/10, or I have, what's my mixed number? 1, because 10/10 is equal to that 1 whole. 1 and 1/10, my other number bond. Okay, so if you subtract it out and you get an improper fraction, I want you to pull out the whole. Now you can draw me a picture if you want, or you can just draw me a number bond and pull out the number bond and pull out that whole and whatever's left and write it 1 or our 1 whole and our 1/10. 1 and 1/10 is our mixed number. All right, should we try another one? Okay, this one's going to be fast. This one is going to be 12/6 subtract 4/6. So 12/6 subtract 4/6. All right, we can already tell that we're going to have 6 as our denominator, right? And now we're just going to subtract it across. 12 subtract 4 is 8. Okay, we've got an improper fraction here. Our numerator is greater than our denominator, so we know that there is a hole in there. If we drew our picture, we'd have 6, 6, and then we'd have some more in our next fraction picture. Okay, so we're going to take that and we're going to pull that whole number out. How do we pull a whole out of 8, 6? Well, we got to look at that denominator, and the denominator tells us how many we have to make a whole. So we're going to have 6, 6. There's our whole. And what's left over to bond with that 8? Well, we've got to have 2 6 left. All right, so we can name this 8, 6, or we could rename it as a mixed number, which would mean the same thing. And we would have 1 whole and 2 6. Or we would say 1 and 2 6. Okay, all right, you are all set on subtracting with like denominators.